How's it going, folks? I'm late. Sorry. Didn't want to be. Just how things happen sometimes. Life. Funny thing life is. Hey, Johnny. Started getting worried, not gonna lie. I'm sorry, man. I appreciate the sub. You're the best, Johnny. You're always worried when I'm late. And I appreciate that. How are you doing today? Let's see. I need to go to my Twitch settings. You're doing great. I'm glad to hear that, man. I was just reading earlier today that there's a new setting on Twitch. Ah, there it is. Training for generative AI that they enable by default, and I have just disabled. Cool. Had to do that. I'd make a note to myself to disable that. Enable by default, not surprised. I know, man. I fucking know. Hey, Johnny, so I know you were excited for Euro Clojure, right? Did you also notice that there's going to be a HeartConf next year, which is basically Heart of Clojure, but reimagined? I don't actually know where that is. So you did not? Nice. I don't actually know where that one is taking place. It's going to be in Europe somewhere, presumably. But I also saw that. So that might be two conferences that I'm going to be in Europe for next year. Heart of Clojure was really good. Heart of Clojure. That was that last year? I think that was last year. That was probably I think that was the best conference I've been to. And I think part of it, to be fair, part of it was just the fact that it was in Leuven, Belgium, which was just such a gorgeous place. It really was. It was a really nice place. All right, so we should be able to spin those up. And then those are not in the correct directory. Man, I'm so out of place here. All right, there we go. Watch bin compile 16. And then jump into this. All right. Finally getting where we need to be. Let's see. What else haven't I done right today? I put out the alerts on Slack and Discord. I did the AI thing. I gotta tell Janet about that in case she missed it. To also do the AI thing. Do the AI thing. All right, last thing I think is music, which I don't have going. All right, here we go. Does this work? Oh, this should not be going through to you guys. Let me double check that. Yeah, that's right. Although it's not coming out for me either. Where the Spotify's okay. Hey, Alex, how's it going today? Your username is asymmetrical. I don't know if you ever considered that. Because you have the 1 on both sides, and then you have the Alex in the middle, and that would be a nice sort of symmetry. But then there's also an 8, which is a pretty heavy letter when you think about it. 8 has a lot of mass compared to like a 1 especially. And then the 8 is only on the right side. And so your username really leans to the right side. I don't know if that makes sense or if that's how other people think about about text, but that's how it works in my brain. Have you already got your talk confirmed for Clojure? No. So has Clojure put up a call for presentation yet? Time to reconsider this. So Clojure 2027. Wow, that's a laggy motherfucker. I don't know if that's the website or if that's just this like nested Firefox. I kind of want to test this now in a different browser. Oh, it's just as laggy. Wow. Huh. Interesting. Yeah, so there's just a mailing list. It's not a certified Firefox moment because it was just as laggy in Chromium. So I don't know if it's the fact that it's in it's nested window manager that maybe is not getting. I would imagine it would get GPU acceleration just the same as everything else. Or maybe it's actually just this website. Let's go to the jank website. Jank. Scrolling is fine. So this is like, wow, man, this website, dude, whatever is like, there's nothing going on here visually, but it is just a slog to scroll through. Yeah. I don't know. That's web dev. Anyway, so to answer your question, Johnny, they don't have the presentation, like call for presentations up yet. So I've not submitted anything. Now I have been talking to the organizer. I think it's 2 brothers or two people. I thought they were brothers. I don't know why I thought that. It's 2 guys who are organizing it. I've been chatting with one of them, saying that I'm interested in and hopefully planting a seed to get me there, but nothing confirmed. It's not that I can't share. I just don't have any more info than that. So we'll see. Hopefully I'll do something there. But the thing is, I don't even know what I would do. I had the talk planned for the upcoming conj. Like that's already submitted and accepted. I just need to make it, which hasn't happened yet. But I don't know what I would present at either HeartConj or what was that called? Was it called HeartConj? No, it was called HeartConf. Yeah, HeartConf. At either Clojure or HeartConf. I mean, more jank shit, sure, but how it differs, I don't know. We'll have to see. So let's see. What were we doing last stream? Because I I can catch you folks up on what has happened since then. And let me take a look. But I guess in order to do that, I have to get to my channel. Oh, we can just do this together. So I think we go to the Jank TV YouTube. When I first set this up, oh, nice. I realized afterward that there were like other Jank TVs, and I was a little surprised by that. And I was wondering, like, how long is it going to take for Jank TV to show up at the top? Apparently, these guys have 1.73 thousand subscribers, but we still show up above that with a whopping 69 subscribers. Let's see. Oh, we did native value throwing, and then also some other exception thing. Right. Yeah, so it is two brothers. Okay. Yeah, I think I got that from the community check-in that the Clojure folks host. Daniel Slutsky. I was in the last one of the, it was 2 parts. I was in one of them, and I think that the Euro Clojure guy, one of them was there, and I think maybe he mentioned the two brothers there. But so what I've been working on is error reporting, and this is already what I was telling you folks about before. And if you're in the Jank Slack or Discord or or you follow me on Twitter or Blue Sky, then you've already seen some teasers for the work that I've been doing. And so I'll show you a bit now, and then I'll show you a bit now for sort of covering what I've already teased, and then I'll show you a little more that has been done as well. So what I've done, the biggest thing I've done since last week, is I have added support for symbolicated stack traces from runtime exceptions, which is something I think if you're just coming from the JVM that you hear and you're just like, okay, so like we get those without even thinking in the JVM. Well, the native world is not the JVM, and C++ had no standard notion of what a stack trace even was. I think that even the existence of a stack as a data structure, it wasn't even required. There's C++ just has like dynamic memory and automatic memory, and leaves the heap and the stack up as to implementation details. But that means that when it comes to capturing a stack trace in a portable way that's going to work on at least Linux and Mac OS and Windows, there was no standard way to do it. And then on top of that, C++ has no notion of how to do JIT compilation at all. That's not even a concept anywhere that's in the C++ standard. And so when you're talking about getting a portable stack trace where some of those frames are also JIT compiled, now we're like, none of the existing even like third-party open source stack trace libraries for C++ supported this. So there was a lot to sort of figure out. Alex says, wait, so it isn't standardized? So stack trace, if we search stack trace CBP, C++ 26, I believe, no, it was 23. C++ 23 added a new stack trace header. However, this is not yet implemented properly, completely by the three major compilers, GCC, Clang, and Microsoft C++ compiler. So it's not actually something that we can rely on yet. And on top of that, it doesn't have, and it probably will never have, support for just-in-time compiled frames. So we still end up with a similar problem. Interestingly, the JVM shows a combined JVM native stack trace when you crash JVM, which I'm pretty good at. Yeah, so that's the thing though, is that the getting a stack trace for native is generally not tough. Getting a stack trace is generally not tough. Getting a symbolicated stack trace is more difficult. As anyone who's worked on mobile will know, you can get a stack trace from a device that's sent to you, but then you'll later need to symbolicate that stack trace because you probably shipped your native binary without debug symbols, so that people have a harder time reverse engineering it, and so that it's smaller. But getting a symbolicated stack trace is harder. And then the next step is getting a symbolicated just-in-time stack trace is even harder. So the last thing I'll say on this here is that the things that we need to tackle are we have symbols coming from three different places. In any like normal JIT execution of jank. We have symbols that are baked in to the jank binary. We have symbols that are that have been just-in-time compiled in this particular session. And then we also have symbols that were loaded from AOT compiled object files at runtime. So if you've already pre-compiled some of your code to object files, then when you go to require that particular namespace or whatever, if there's an up-to-date object file, we'll load that. And the way that each of those three stack frames is resolved is different. So if it's the first case, which is like the symbol belongs inside of the jank binary, then that's part of the dwarf information of the jank binary on Linux. If it's a just-in-time compiled frame, then LLVM is emitting dwarf information separately, assuming that you add the appropriate plugin. But then you need to handle the relocation of addresses, and there's actually some pointer work that you need to do in order to be able to resolve those properly. And then the third case is an object file, and the dwarf information for those is stored alongside the object file, which you then need to go back into in order to be able to grab. So this was some bullshit, let me just say. All right. This was some bullshit. But what we have now, oh boy, what we have now, let me show you. So this is a file that calls subs, which is going to throw whenever you give it a string that's nil. And we can see here, frame 4 comes from test.jank line 2. And our symbolication here grabs the namespace. So we're able to grab the namespace and the name of the function, as well as the arity that we're in. So we can specifically say we're in user foo arity 0, and that is fucking gorgeous. And then we skip ahead a bit and we end up in Clojure core subs arity 2, which makes sense because we're passing nil and 1. And that's in Clojure core. So we get source information there. And then that calls into a C++ function, which ultimately throws. So we don't have column information because of implementation details that we really can't get around. But at least we can render that particular line like just an underline under that particular line. And so in this case, it ends up pointing at exactly what we want anyway. And that will in a lot of cases. What does it say if you have a variadic arity? It'll say that the number of the arity. And so if you have like A and then a rest args, then that would be arity 2. Because that's actually how that's implemented. Because the rest args is just a sequence. Does the code have to exist in a file somewhere? In order for you to get a symbolicated stack trace, yes. Because of the way that the logic works. Well, in order for you to, let me clarify, in order for you to get this nice sort of rendering, yes. If you just eval like a string, then instead this would say like user underscore foo underscore some number underscore 0, which is what the actual raw symbol looks like. I think in order for us to know that a function is a jank function, it needs to match that pattern, and the source file needs to be a .jank or .cojc. Because we're not, like right now anyway, we're not just going to rename arbitrary symbols that match the particular pattern of Jank's generated symbols, because that might be surprising for whatever C and C++ code is out there. So right now we gate that based on whether or not the source file is .jank or .cojc. But anyway, so this has a couple of big implications. So first off, we're able to get a nice symbolication of the namespace and the function name, as well as the arity. This builds on top of DJ Blue's source information that we already had, and that's necessary for all this to work. And then the next thing is, in order for us to render a snippet, we need to actually have some sort of source information. And the way that Clojure works is Clojure will, when it catches an uncaught exception, it will then scan the stack trace to try to find the first Clojure frame that's not part of like a Clojure core, or it's not like a core library. And so we have that same sort of functionality where we're going to scan through and we're going to skip all of these guys until we find this test.jank. And then that's actually what we decide to show right here. Because if we didn't do that, then we would actually end up underlining the implementation of Clojure core subs, which is the most like recent jank file, and then we would underline that and say, an exception was thrown here. But that's not very helpful for you. We want to underline your source code. And so the fact that we have this source information and we have the symbolicated frames now means like we have everything that we need in order to find what is a good source to actually show. Now, this is what leads us to not have the column info, is that realistically we can only get the line info. We can only get the file on line here for jank files, but that's going to work well in most cases anyway. So that allows us to get a nice snippet, and this plugs right into the normal rendering of the code snippets that we have. And so that way we can render the actual exception message, the snippet of the most recent jank code that you have that would cause this, and then also the stack trace that has the pretty symbolication. So this is what I've already teased, and the only new thing here is this guy, this additional line here that gives us a link to a dedicated page in the jank book for this particular error type. And so from the very start of this whole error design in jank that I did in Q1 of last year, I wanted each error to have an ID. And so I have them in categories, and I have, and then I have unique names for them as well. And they're human readable as well. It's not like E1033, you know, it's runtime / uncaught exception. And so this runtime / uncaught exception maps directly to this runtime / uncaught exception here in the book. And so we have a dedicated page. Now, this link is not going to work because I'm still on a branch right now where this stuff hasn't gone into main, which means it's not actually in the jank book yet. But if we were to look, it's not in the published jank book yet, but if we were to take a look at the actual page here, like this is the markdown file for uncaught exception. That gives you some information about, you know, why this happens, what you can do about it, and depending on the actual error, sometimes there's a lot more than we can do here. So, for example, like a invalid conversion. Why do we have both of those? I think we only want one of those. Let me open up this guy. Yeah, we want to delete this guy. This is an old one. So like invalid conversion has some more information about implicit conversions and what you can do in terms of like opaque boxes and trait conversions and blah, blah, blah. And so it also links to the relevant documentation for native values. So hopefully when you run into an error like this, you see it, you're like, I don't quite fully understand that. You click the link, you get some more info. It links to the relevant docs. Like that's intended to be a really nice user experience. So I'm pleased with that. I think that we have like 115 of these error types right now. And so getting like good, productive, helpful text for all of them is going to take some time. Like right now, I have a page, you know, for each of them, but for some of them, it's like, it's pretty bare bones, what the error is and how to fix it. You know, it's like, you have an unterminated string, and then the mitigation is like, add a closing quote, you know? So there's not always going to be helpful stuff, but I think a lot more of them can benefit from the sort of treatment that I've given to these. It's just that when I was filling these in and I came across ones where I was like, oh yeah, that's clear what I want to do there, then I just went ahead and filled those in. And some of the others, it's going to, we're going to iterate on it. It's going to get better. How about a jank debugger as a plan? It should not be needed. Should not be needed. I think that a native debugger with the proper source mapping and then the ability to render your Clojure values should work fine. So DJ Blue's already done some work to add GDB support for rendering like jank objects and debugging jank code. He did this with his work that added the source information for jank files as well. So you can actually with his GDB plugin that's part of the jank monorepo right now, you can step through jank code and print and print the actual values that you're working with, and they'll print, you know, if you have like a persistent vector, it'll actually print the Clojure form of that when you try to print that value in GDB. And so that's pretty cool. It's very rough. It needs a lot more polish, but my point here is that I don't think that we should need to reinvent debuggers in order to work well with jank, because at the end of the day, like jank is just a C++ program, and every jank program is just a C++ program. But we do need to have some extra logic in order to be able to handle the niceties of things. Anyway, so this is basically what we're looking at for like what should be expected from a runtime error in jank. Runtime error meaning some exception that was thrown at runtime. Compiler errors are different because they don't give you stack traces. So if I were to, actually I have that open. If I were to do something like subs t, and I do that, then you'll notice we don't have a stack trace here. And this is a different test.jank. Right. So Clojure gives you a stack trace here, but it doesn't. I think maybe it used to. Before Clojure CLI, whenever you get an error like this, you just get a full stack trace. But that's kind of hidden away now. But this is cleaner than when you have this whole stack trace here, and so we try to like not show the stack trace if we don't need to. How about macro expansion exceptions? Sure. So we have tests for this sort of thing. Source macro. So let's do I guess we'll do this simple jank run input. This is gorgeous. So you have some macro mydef that takes in a name and a val, and then this is expected to be a symbol here. Now we pass in a vector, right? Jank allows you to track the value that you passed in, as well as where the actual error occurred. And so you get the macro expansion info, you get the actual place where you need to change, which is a symbol is needed for the name here. And then you also get where in the macro it was actually the problem, where in the generated code it was actually the problem. Now you only get this if you use syntax quoting, because syntax quoting gives you more source information than if you build it synthetically. But that is, oh man, that's nice. If we compare that to what Clojure gives you for the same thing, it just tells you line 6, first argument to def must be a symbol. And so it doesn't tell you like how it actually lines up, you know, doesn't give you any nice underlining, anything like that. Gives you enough, right? Gives you enough to solve it. But if you compare this to this, it's night and fucking day. As it should be. But yeah, there are cases where like we have a synthetic case where here, rather than using syntax quoting, we're just using a list to build up the data. So if we do a jank run of this guy, then we can't actually point at the if, because we don't have source information for that. So all we can do in this case is about as good as what Clojure does, which is point at point at where the actual macro was expanded and then say what the problem was. In this case, we just have an if, we don't have a condition, we don't have a then. And so we can say, okay, each if needs at least a condition and then a then form. But it's still significantly better than Clojure because, well, we get the nice, we get the nice error ID that then has a reference you can look up. We get the code snippet, everything like that. Are there any other? Oh, yeah. So I'll skip this one. I'll show you this nested with reparsing. This one's pretty crazy. So here's the thing. When we invoke, so this is a mydef that was the same sort of thing as before. The only difference is it's nested within some other macro expansions. So this shit's pretty like tricky because we have a macro expansion here, we have a macro expansion here, and then we have a macro expansion here, right? And so but when we want to report this and we want to show like where we're expanding from, we don't want to say, oh, well, we're expanding from here or we're expanding from here. What we really want to show is we're expanding from here. And so that's why this test is nested, because you have nested macros. But the other thing about this is that you have reparsing. And so the thing here is that foo, the keyword, doesn't have source information. And that's because keywords don't hold metadata. Keywords don't hold metadata because they're interned, they're deduped. And so you can't, you just can't put metadata on one, because then you'd have the same metadata on all of them. But source metadata is what we use in order to be able to point at things in this particular error snippet. That's how we do it. But some things like keywords and also numbers like integers and decimal values, they just don't support metadata. So how can you underline them if you don't actually get source information from them? And so jank has the ability to do what we call reparsing, which is basically where what we do is when we're building the def, if there's something wrong with the name, then we'll create an error, and the error's note here will point at the source of whatever is there for the name. But we have a fallback, and we say if the thing whatever is there, like in this case it's the keyword foo, if it doesn't have source info because it doesn't have meta or some other reason it doesn't have source info, then take the source info from the def list, right? Because this whole list that creates the def generally has source info, and go back to the file and reparse. Start at the start of the def and reparse until we get to this sort of second element that's inside of that list. And then once we get that parsed value, the parsed value has source info. So even if you parse a number or you parse a keyword, the data that we get from the parser has the keyword, has the number, and it also has source information on the side. Not in metadata, just on the side. That's the output of the parser. Everything has source info when we get it from the parser. It's just that it only goes into metadata if it can, once it makes it into the runtime. So basically, we rely on going back to the file to reparse by knowing the source location of the start of the def in this case, and that allows us to get precise errors even when you're providing data that doesn't have source metadata. So if you provide a keyword here, if you provide a number, that's still going to work. This was Ambrose, the type Clojure guy. This was his idea, and it's worked out really well. Because if you do, I wonder. So the simple way of failing this is if you just do like def 1.2, you do a jank run. So being able to point at this 1 right here, because 1 doesn't hold, it can't hold metadata, like this relies on reparsing. If you do this with Clojure, I mean, it's probably... Yeah, so here's what it does. Clojure can't point at the position, the precise position of where the symbol should have been, because it's not a symbol, it's a number, right? And it doesn't have metadata, and so it just gives you the first column. It just points at the start of the def and says, well, the first argument to this needs to be a symbol. I think, and let me double check this. So if we do foo bar, what is Clojure going to do here? Oh, well, it doesn't give good source info there either. Yeah. All right. Well, never mind. I was going to say, I think Clojure gives more precise source info if it's a symbol, but it still doesn't. Hey, Mohammed, welcome to the stream. Hope you're doing great. Okay, so yeah, what I've been working on this past week is the main thing I've been working on anyway is getting all these runtime errors looking sharp. And with where it is now, I'm pleased. But what remains is a lot, even just in terms of runtime error. I know we talked about C++ errors, C++ interop errors last stream, and there's still a lot that's going to happen for those. But before I even get to that, there's a lot more that I just want to do to clean up the runtime errors. So let's take a look at what we're going to do today. We could do this. You know, I didn't actually fully plan out what would be good for today. Because there are some things that I do that are just not very fun, you know? Like this one is what I would be doing today if I were not on stream. Is that I would go through the 209 different throws that we have in the runtime code, and I would take all of these error messages. So we have some pretty shitty error messages, right? Just like not comparable, and then some object type. And I would change them all to be good error messages, because that's, you know, we want. So I'm kind of working on a style guide for what error messages should be, and that way we can have that enforced. I don't know, maybe we can even get Copilot to like enforce that as part of the code reviews and PRs. I don't know about that. We'll have to see. But either way, we'll have some clear guidelines for how errors should be written whenever new code is being added. And this way, whenever you get whenever you get an error, like this is pretty nice. The first argument to subs must be a string, not nil. I like that, you know, like you know what you're working with, subs, you know that you need a string, and that you know that you've been given nil. But if we did something like, what's something I know that I think this is something that gives a bad error? Yeah, right. Not derefable nil. Like this is not a this is not a good error message. This is like a log line, you know? It's not something that the user is, it's not something that's written for the user who's looking to fix their code. It doesn't even use correct grammar. So I've tolerated these, and by tolerated meaning like most of these are from me, but I've tolerated them from other people as well because they're just copying what I already had. But now we have a couple hundred of these really bad exceptions, and we need to go through and actually clean all those up so that way they fit within the quality bar that I'm trying to set for the runtime exceptions. This is what I would be working on today, but I think that would be quite boring for 20 to 30 people to watch me comb through those errors and change the messages and try to figure out what good messages are for each of those. So let's do something different, and then I'll have that done probably for next stream. Macro error sources are all jacked up. Let's take a look at that. I don't actually understand that problem. So let's try to solve it. So if we have some macro foo, and that, let's say we take in a condition and then a then, let's call it if, big if, and let's do an if condition then. And then def and foo, and then let's say big if true, throw meow. Oh, and then call. This is fine. So we see that we are on line 7. So that still works. Okay. So what happens if we build this synthetically? Still fine. Yeah, because we're inside of a def in here, and we're also inside of this if macro, and that still works fine. What is the... I'm trying to remember where this would actually show up incorrectly. Because I know I brought it up before, and DJ Blue confirmed that macro sources were wonky. But what was it? Maybe it has to do with splicing. And then, so if we take this, we do this, whoop, that, and then we do this inside of a do. Then we do Yeah, I don't know. Maybe it all works. I mean, I guess I'm not upset that I'm not able to break it. I guess it's nice that that seems to be working well. All right. I guess we'll leave that for now. I'm going to leave that on the list though, because I think it requires a little more scrutiny. I just don't know where. But it's something I want to keep my eye out for. Okay. I guess we'll do this. We'll do this first one, which is adding exception info. So this is another thing that DJ Blue was asking for. So let's do it. I don't think that there's... All right, I don't think that there's... Nope. Oh, hey, DJ Blue. I think we're avoiding the problem with line since the source code in core.jank is explicitly skipped. Also, are we going to have throwable to map? What does throwable to map do? The fuck is this site? Oh, Flexiana. I appreciate Flexiana because they do like Clojure Corner and stuff, but I don't like this site because the entire first half of my screen is two nested sidebars. And then like I have everything else over here. I don't want to read the stuff over here. Constructs a data representation for a throwable with keys. Cause, phase, via, and trace. So causes a message. What is phase? This is really poor example here. I guess we'll just take this. I see. So you also want a data representation of the stack trace. I think we can do it. is gonna be kind of a pain in the ass. Let's do it. Let's do that. Just for you, DJ Blue. Okay, so we're gonna call this exception. It's under reader conditional. Did I call that exception K? I did. Runtime visit. You always add it later. Well, no, I mean, that's kind of like, it's kind of what this whole exception thing is going to be used for, right? We're basically just going to put those fields inside of the exception object. Let's go to opaque box and yoink that. Exceptions don't have meta, right? I don't think so. Okay, so an exception. Now this is one of the annoying parts, is that resolving stack traces, symbolicating them, is expensive. Like really expensive. So that means that by default, when we generate a stack trace, we need to generate a raw stack trace. And then we need to lazily resolve it only when necessary. But when we do resolve it, we want to cache that because we don't want to have to resolve it more than once. So that means that, but the way that the library that we work, CPP trace, works is, the library that we use, CPP trace, works is that raw traces and resolved traces are different types. And so that means that we're going to need to store both. Let's start. Let's start with a raw trace. One thing we should also consider is how this interacts with Clojure test reports. Yeah, right now we have a lot of that stuff in Clojure test commented out. Honestly, now that we're going to have a good support for symbolicated stack traces with sources and everything like that, once this branch gets merged in, we're going to want to go through a Clojure test and ideally add all that stuff back in. And if it and if it can't be added back in, then find out where the gaps are. So we'll just call this raw trace. Incomplete type. What constructors does this have anyway? It is default constructible. But yeah, we're going to get a unique pointer to it because we don't want to have to include it here anyway. So instead we include memory. Memory is already included in pretty much every other place. Yeah, because this is going to end up affecting the precompiled header, and we don't want to pull CPP trace into the precompiled header. Okay, so object behavior is pointer free. No, this won't be pointer free. So we're gonna have a string for the, what was it called, cause. And then I still don't know what phase is. Phase is nil on this one. I'm gonna ignore phase. Tell me if I'm wrong about that, DJ Blue. Via is a cause chain with cause keys. So this only gives the latest frame. And it's not the user code. This is actually the frame that throws. In order to be able to do that, we're going to need to know, I think it's very odd to call this cause. I would call this message. And then the cause should actually be another exception ref of the thing that caused it. So in the jank object, I'm going to call it that. We're going to do another exception ref cause. And this is the thing that actually caused this. And so that you have one exception that causes another exception that causes another exception. Those end up being in the via. Now we'll call it the same in the data representation. Just because that's an API provided by Google, provided by Clojure that obviously code already is built around. Blog explains the phases, read source, macro, syntax check. Yeah, okay, those are not going to apply. I don't subscribe to Clojure JVM's phases. Thanks for that link, Omniphobic. Yeah, very different compilers. So we'll have our message and I don't know if we want to. Yeah, I think we're not going to set the others. We'll see. Okay, so this is created by ExceptionInfo. So let's take a look at Clojure core ExceptionInfo allied top frames. So it has a map of the data. Extends runtime exception. Is runtime exception Java? Yeah. And then X data says get data. And then X message says get message. So we need the data. We need some data as well. Should we call this exception info? Seems like we should call this exception info. No reason not to. Move this guy to exception info. And then we got to jump back to here. Whoop. Info. Okay, so the cause is another exception info. Where were we? Clojure. So the cause, I mean, which is, I mean, in Clojure it's another throwable, but we have no concept of throwable in C++. So this is really only going to be viable for just exception infos thrown being the cause of other exception infos. Then data, message, data message cause, data message cause, and stack trace. Okay, so this should be everything that we need. Yeah. Okay, so let's do yoink all this into here. Exception info. That's not going to be right. That's not going to be right either, but we don't want any of that. Okay. So this is going to take the string and tagged literal. Wait, is that a copy paste error? It is. Nice. Good thing nobody's comparing opaque boxes. exception info. So what makes exception infos equal? Are they equal only by identity, or are they equal based on the value that they contain? Let's check. So xinfo takes a message and a map, right? Yeah. So does this xinfo equal this xinfo? No, it doesn't. Does Clojure have a hash function? It does. Right, so the hash of them is different and they're not equal. Okay, so we're just going to do an identity check then. So we'll just check if return this is equal to the address of, actually we'll return, we need to adjust the pointer correctly. There we go. And then here we'll do like a volatile. Oh, we just don't need to implement this. Yeah, actually, what's the default object equal? Do we already get identity checking? We do. Cool. So we don't actually need to implement any of those. And hashing, let's see, this gives us object by the blah, and then that gives us hashing. But yeah, nice. So we just actually delete all of that, and then we can delete all of that. Nice. Okay. Now I'm out of water. Let me come back with a bigger cup of water, because I normally have 1,000 milliliters, but I only have a little guy this time. I'll be right back. All right, so now we just need to make xinfo actually construct these guys. Oh wait, did I not update visit? Easy. I see a pattern from Phobic of you saying easy in here. It's always easy, right? But it weren't easy, we wouldn't do it, right? You just make everything look easy. Oh, wow. What a sweetheart. Right. So let's open up Clojure Core. And see what ExceptionInfo does. So, right. Okay. So, right. Yeah, we're just creating a map right now. With like not even the correct keys in there. So we want to create a ExceptionInfo object. Probably want a helper function in the runtime of jank that creates an ExceptionInfo given a message. And then what we'll also do in that function is that we will capture the trace. Yeah. Okay. So let's do runtime core. And so we'll just do ExceptionInfo ref, and then we'll just call this xinfo. Oh, right. So we need, this takes message and data. So we need to take a data that we're not going to define that here. We're going to define that in here, and then xinfo, ExceptionInfo, yep, and then ExceptionInfo, and then we need to jump over here. So this takes in the object ref const data. Data. Okay. And so in here, we include visit, so we get everything. So we want to do two things. We want to create our xinfo. And so for that, we'll do a makebox of object ExceptionInfo. We'll give it the message. We'll give it the data. That's that. Now we need to generate a trace. And so we'll do a ret raw trace is equal to cpp trace generate raw trace. And then we'll just return ret. And we just need an include for this guy. CP trace basic. Let's see. We get into this water. No viable overload because generate raw trace is going to give us a raw trace object. And what we're actually working with is a unique pointer. So we want a make unique. Raw trace. CBP trace, certainly making that look easy. You get it eventually. So that was already compiling, I think. Have you scratched before? Question mark, question mark, question mark, question mark. Scratch is a programming language? Is that like a Google thing? Yeah, it is a programming language. I don't think I've used it. I think I'm familiar with it, but it's not something I'm familiar with beyond a cursory level. No. It's complicated. Okay. Yeah, I'm not a Scratch expert. I don't know if I'm an expert at all. Just a dude who doesn't know Scratch. I need to opaque box. So I added this under exception. Where is that? This keeps happening. CUDA expert? I'm definitely not a CUDA expert. Reader conditional. Welcome to the club, mashed potato. You prefer your mashed potatoes with skin or without skin? Sorry, I paused there thinking about mashed potatoes without. There's no wrong answer. Exception. What about everyone else? Gravy on top, of course. Of course. Everyone else, with skin or without skin mashed potatoes? What do you think? I will have to say, I leave the skin on. I scrub it. I have a potato scrub brush. I don't know if you guys use those. If you peel the potatoes all the time, I guess you probably don't need a scrub brush. But I have a little potato scrubber, like a bristle brush, and I scrub it under the water, and then I chuck it in the pot and boil it alive, and then I guess I chop it up so it boils faster. But yeah, I prefer the skin on. I was wondering who was gonna take it in that direction. Bastization does it. About application of size of incomplete type. Raw trace. Deleter. Yeah. So the problem here is not clear at all from the message, but it's actually just saying that we need to include CBP trace. Speaking of potatoes, and how I like the skin on my potatoes. You know what else I like that a lot of people don't like is raw broccoli stems. Not the little florets at the top. Those get all the attention for broccoli, but just the stem. Just the crunchy, crisp, juicy, semi-sweet stem. That's so refreshing. I eat broccoli stems like candy. They're so good. God damn, I want some broccoli stems right now. broccoli stems, tree trunks? Nah, man. Broccoli. I mean, I guess I need to give tree trunks a better shot. Who doesn't like tree trunks anyway? What's that tree trunks voice? I don't remember right now. But she's all like, hey, Finn, do you do squats? Oh, she's got like a southern voice. We were making a runtime core function, called ExceptionInfo, and we did that. So now we just need to call that function. And we need to call that function from over here. So we have CPP, jank runtime, ExceptionInfo, takes a message, takes a map. And then we need to have another overload that takes a cause, because there's no taxation without causation or something like that. Cause. So do we assume that the cause is... Realistically, we can't assume that it's an object ref, or we can't assume that it's a exception info ref. Here, data jank nil. So yeah, in order to assign this, we're gonna have to say, okay, so if cause is sum, then we'll try to do a try object on there. Mash is back. Tell a friend. Did Mash ever go anywhere? I feel like mashed potatoes have been a thing for a long time. You went to KFC. You're making me hungry for mashed potatoes and broccoli stalks. All I have here is a chocolate peanut butter protein bar. I suppose that'll have to do. Okay, so now we have an X. Now we have a cough. Now we have an ExceptionInfo that actually constructs our ExceptionInfo messages. That's it. We need to change XMessage and XData and XCause to do the right thing for those. That right thing is going to be to expect or to try that the object is an ExceptionInfo, and then to pull out the message or the data or the cause. So I'm going to create runtime functions for those as well. So let's do something. So we have the message data cause. Message is going to be a immutable string. X message is going to take in some object ref const. We're just going to call that O. And then data and cause. So for cause, we can do an exception info ref. And then for data, we're just going to get an object ref. All right. So for each of these, we're just going to do a return try object, object exception info, message. This guy's data. This guy is cause. Funny thing is, I don't know what you're talking about. Oh, that's okay, bruv. Nobody does. Jank runtime x message. It's not a function. Data cause. All right. I think we're good. So we still just have a raw trace for our exception infos. And we're going to need to resolve that, but I don't know when. And we need to resolve it, and we need to cache it. Who do you think you're fooling, Tater? Huh? I guess everyone who clicks. So the toString of an exception info is actually this exception info string. It doesn't give the... that doesn't sound right. Because when I constructed this, I got this whole thing. I don't like this rendering. Why do we do this? Clojure doesn't have any other objects that do this. Okay, but the code string, if we were to prn, yeah, we get this. So we do need to resolve in order to get this formatted output. I also noticed that it's automatically formatted. I don't know if you also noticed that, because if we did like if we did a throwable to map, this is not formatted. But this is formatted already. Isn't that interesting? Seems like it's a lot more, it's intended to be read top down. All right, fair enough. So let's see. By default, the empty toString just calls the other toStrings, so I think we really just need to override that one. So we can say using object toString, and then void, and then string builder. And then we can just override these two. There we go. Is that going to compile? What's this IDE? Ollie from Solly. This is just Vim. NeoVim. Not technically an IDE. What's Vim? NeoVim. NeoVim.io. NeoVim is a modern, fast, and feature-rich editor that is fully compatible with Vim. Vim is an old editor. Vim first showed up in 1991. Okay, so we're gonna need a resolve function on this, because if we want to build this up, so it does error. And then cause, which is quoted. That's our message. Then data, then via, then trace. Data. And that's going to be data to code string. Via, which is just, let's say, going to be empty for now. And then the trace. And let's say that the trace is empty for now as well. Yeah, because we're going to need to crawl through that trace after we resolve it and try to turn this into some, like, these are actually symbols as well. I don't even know if we can do that with C++. Those might have to be strings. Because there can, yeah, DJ Boo's not going to like this. Because you can have template parameters, and that's not going to be... Template parameters need to have spaces between them. Or commas, and commas are white space in Clojure. And so I just don't think that we can get away with symbols here unless we strip all of that out, which maybe we can do. So if we get in a jank REPL now, and we do an ExceptionInfo of meow empty map. Oh, I need new lines for all those. So, whoop, new line, new line. Yeah, this is basically what we're getting here, except that's only one indent, and that is 2. Noted. Now it's 1. So there's our data, and now via. So it includes itself in via, and the first form, or the first frame of the trace. So we'll need a helper that takes exception info and gives exception info to via. It's going to give us a type. I don't know if type makes sense because they're all going to be exception info, and also we can't represent jank types as runtime data, so it'd have to be a string, and then it's always going to be the same thing. Probably doesn't matter. I assume that type here is, maybe it's just a symbol. I don't actually know if that's like a JVM type thing there, or if that's just a symbol. But it doesn't matter anyway, because this symbol doesn't make sense in jank. So I'm just not going to include that. But we'll have message data and at. So yeah, let's do a static, we'll just say object ref. Cause to via. So we're going to want a map, probably just easier to do a map transient. Yeah. Just yoink that, get us a transient map, and then with the transient map, then we can, we need to include that. Runtime detail. Where does that come from? Where the fuck does that come from? Where do you live, dog? Oh, that's just runtime detail type. Okay, why don't I have that? Okay, and then transient map, I should be able to do like a insert, update if it exists. Insert or replace, okay. Yeah. So we want to insert, and then we're dealing with message data and at. Those are keywords. Probably want to cache those. Why do we not have that? Message data. I'm going to need an expect OK on that. And then at. And at is going to be a vector. Yeah, I don't know about that. So message keyword and then message. We need to box that. And then data keyword and data. And then at keyword. And then we're going to need here a persistent vector. Oh, insert wants one thing. What is it? Just take a pair? Value type? Value type's a pair. Okay, fine. Is there like an in place? There's set. Inserts association key value of key size. Yeah. Okay. Set. No matching thing for message. Message is a mutable string, so that should work. I think we're just missing the include for core make box. Yep. And then last thing is we just need this vector. So we need to take the 0th frame and then we need to turn this into a thing. So for this, we're gonna need a way to take stack trace frames and then turn them into this shit. So let's see what we can do. Via goes to a new line. And then enters that, and then we do this on the same line. And so this will be cause to via to code string. I want to call this guy with all right. That's not going to be pretty printed, the to code string for this. Oh well. So now we need to loop through the other causes. I don't want to worry about it yet. Finally caught a stream. I'm glad. How's it going, Joseph? What's up, brother? Just woke up on the other side of the world. Oh, cool. Where are you at? Thailand. Nice. I lived in Southeast Asia for a while. I do miss it sometimes. You're trapped there? Wow. Sorry to hear that you feel that way. I'm glad you're excited for jank. I appreciate you taking the time to jump in, check out the stream. 7 years you're trapped there? Damn. No escape. Escape from Thailand. All of these sound like cheesy novels. Okay, so that's our ad. Oh right, no, we don't have the ad. We don't have the ad yet. Let's see what we have though. So if we yoink this, we need a new line. So there's our cause, our data, our via, message, data. All right. And now we just need to do the tracing. And so that includes the tracing for the trace here, as well as for the first frame that we're going to put an at. But in order to get that, we have to resolve the stack frame. Resolving the stack frame is going to mean taking our raw, well, we're going to need to resolve the whole stack trace. We're going to need to take our raw trace and we're going to need to resolve it. We're currently only doing that in this place. Is there work that we need to pull out of here to make it more portable? Yes. No? Damn. So we have this code in here that makes our symbols nice and purty. So we have purtify symbols, and this is what gives us the nice arity. So this is the namespace, and then function name, and then the arity. We're gonna need to do this transform frame. We're only doing this right now when we print. And so basically we need a function that takes in a resolve stack trace and gives us back a pretty stack trace. And then we can later print that, rather than trying to do this all while we're printing, I think. But the other thing is that we rely on this formatter to do things like prune the symbols. Prune the symbols. So if we were to do, let me just check. Yeah, see, so like this shit's not going to be valid a symbol. It's not going to be a valid symbol. I mean, this alone wouldn't be a valid symbol. And the keywords, the double keywords, or the double fucking colons, those are not valid Clojure syntax as well. It has to be a string, which means that we're breaking the shape of this output, but I don't think there's much we can do about it. Just saying, I didn't want to I didn't want to break the shape of what fucking throwable to map gives, but C++ is a different beast than the JVM. And like, we're already trimming template parameters and return types and everything like that, and it still ends up being nasty in terms of trying to treat it as a symbol. All right. So is there a function not to print from the formatter, but to get a string? Oh, fuck yeah. There's a function called format. And a bool for color as well. What is that in default to? Always. So we're going to want to pass false there. Cool. Yeah, so we can actually just format this to a string. Hey, Cogwheel, that's disgusting. But also clever. Pimple is a C++ idiom for those who don't know. This p-imple is a pointer to implementation. And it's a pattern that we use in C++ in order to hide implementations, generally for compile time performance. And then the reason why it's called p-imple is that historically, we're going way back here. There was this thing called Hungarian notation in C++, and C as well, where the types of variables was encoded in the variable name. And so pointers would start with P, and enums would start with K, obviously. And integers would start with I. And this is exactly what leads to the Windows bullshit. If you ever worked with the Win32 API, you'll have like a long pointer to constant wide string. And then that's like your prefix for your fucking variables. And so you'd have like long pointer, constant wide string, and then player name. And so all of this LPC WSTR shit is just telling you what the type is. And then the actual name, of the variable follows after that. Fortunately, this kind of died off. But I do still see it. I just saw Hungarian notation recently from some game dev folks who, of course, are using Windows and are shipping their game on Windows, but they're using Unreal. And I don't know if the Hungarian was coming from Unreal or if it was coming from them, but I saw it and I was like, wow, I haven't seen Hungarian notation in a long time. But it is true that like pointer to implementation, the pimple pattern is it's a couple of things, right? It's the pattern of hiding things outside of the header, and also it is a little bit of history for the Hungarian notation making its way into the name of a pattern. T is common for C stroke stuff. I think that underscore T is not part of the Hungarian stuff. Maybe it is, though. I think because Hungarian was normally a prefix. Also, hey, Sorcerer. Reverse Hungarian notation. Oh, man. Pretty much. That's kind of what underscore T is. Yeah. It's, you know, especially in a statically typed language, it seems pretty silly to encode the variable type into the name. I remember that when auto came out, auto was first introduced in C++11. A lot of people who I heard express concern about auto were like actively concerned, and I've actually seen this. I've seen this recently. There's misunderstanding around auto that it somehow makes things dynamically typed, and I just wonder if those Hungarian notation people felt the same thing. You know, like if I don't write the type inside my variable name, I might lose it. Who knows where it's gonna go? And so might as well just put it everywhere we can. But yeah, I remember it was actually within the last year. I was talking to someone about C++, and they were saying how like the usage of auto was dynamic typing, and I was like, nah, bruv. That's it's not how it works. You're a C# guy, same thing with var. I've heard that, nah, man, we shouldn't use dynamic typing. Yeah. Using auto with the wrong Hungarian designator. You know, so, all right, here's a thing. For all of you, for all my auto/var homies out there, if you ever have any naysayers, the strongest argument for auto is just simply the ability, like the flexibility to be able to change the type and not break and not have to like go through every single usage of like, let's say a function, right? You change the return type of a function to something that is structurally the same. So before it was a 2D vector that had X and Y, and now it's still a 2D vector that has X and Y, but it's a different, it's a different nominal type. If you were to change that, and every call site that was calling that had like, okay, my nominal type, vector 2D, and then V, and then initialize it with the function call, then you're going to break every single call site, because now you're returning something that is structurally the same, but nominally different. This is the difference between, I'm using these terms here because this is the difference between nominal typing and structural typing. And these are like, this is such an important classification to make, especially in C++. Nominal typing is what sucks. It's like when Rich Hickey shits on type systems, he's talking about nominal types of like, you have some foo type, and then you have a foo factory, and then you have a foo mover, and you have like all these things. Structural typing is like, I don't care what type it is, as long as it has an X and a Y, right? Which is basically what we do when we do Clojure, right? You're like, oh, give me a map. I expect there to be an X and a Y inside that map. I don't really care about anything else. When we write templates, that's how it works. It's basically structural typing. You're like, I don't care what type this is, but I'm going to try to access X and Y from it, and that's gonna, as long as that works, then we're cool. So if you, at every call site, you're like hard coding whatever type was there, you're locking yourself into that nominal typing. And if that type changes, even if it's structurally the same, you need to go through every single place where you're calling that function, and you need to go update those types. I used to have to do that back when I was writing C++, and we didn't have auto, and it sucked. Because when you try to refactor anything, you just have so many different places where you're just like, oh, yes, this is clearly broken. I just need to rename this thing. Now that I use auto, and I like in Jank, for example, we just have a style of like auto is just used by default. Like whenever you can use auto, it's just auto. Now I can change the return type of a function, and everywhere else is just, for the most part, it's just going to work. I don't need to worry about all the different places where that was called, assuming that I'm structurally giving the same thing. And that's a huge benefit. I guess it doesn't matter as much these days because people don't write code anymore. You can update the nominal type by rename your name by ref using LSP. Sometimes, yeah, sometimes you can. But sometimes, just as much, just as often, in my experience, you cannot, especially in a large code base. I've found that LSP works well with the translation units that are open. And not so much with all of the other code that's in the code base. I think if you were to hop into like the LLVM code base and try to do like an LSP rename of something, you're going to end up with a pretty incomplete rename. Even in the Jank code base, which is just so much smaller than LLVM, I end up with incomplete renames whenever I try to do LSP renaming. That's not to say I don't do it, because I do start with it. I might as well use LSP to get me as far as I can. That's exactly what the tool is for. But it's not as good as it should be. Yeah, exactly, Sorcerer. So I'm really pleased when I see people using structural typing, because I think it makes a lot of sense. I think it makes a lot of sense. I really like it. Welcome to the club, Software Tools. What the fuck were we doing? Right. Frames, stack traces, resolving. My favorite streamers live. Oh, is it Soding? Hey, Matt. How's it going, brother? How's the house, man? I hope everything's going well with that. Just took out rotting deck. Nice. Did you deck it? Is it all decked out now? Man, deck is such a flexible word. I'm just realizing that now. Mostly a side effect of the necessity of typing being gradual, as opposed to, yeah. There's so much more I want to do with types that I don't allow myself to work on yet. But the interesting thing is we can already do quite a bit with types in jank because jank just uses C++'s type system. And you can do a lot with types in C++ if you're adventurous, and you can still do a lot if you're not. It's barely holding together. One day I'll rebuild it, but not today. Well, I hope it's not all bad, and that the rest of the house isn't falling apart. Miguel, welcome. Appreciate you. Hope you're doing great. Soylent Ding. Nice. Welcome. Of these stack traces? Oh yeah, Matt. So I was saying before, this is some of the new work. I've been working on the error reporting, and now we're able to, this is a runtime error. We're able to get symbolicated stack traces, and these the symbolication comes from 3 different places. So in this one stack trace right here, we have symbols coming from 3 different places that are handled entirely 3 different ways. So these frames up till here, these are all part of the jank binary. And so they're resolved as part of the dwarf information that's statically in the jank binary. This one was just in time compiled from this code here. And so its dwarf information was generated by LLVM as a separate in-memory object. And so we need to use a separate in-memory symbolication for this, and we need to apply relocation to the addresses as well. And then we have Clojure core, which is comes from a third place, which is this is loaded from a precompiled object file at runtime. So this is a debug build of jank where it doesn't have Clojure core baked in. So it starts up, loads this object file that has Clojure core and all the stuff in it, including the dwarf information, which is the debug information. And so we need to keep track of, I have an LLVM plugin that has to keep track of which symbols belong in which object files. So that way, when we lazily symbolicate, we can go back and grab the dwarf info so that we can properly do this. So there's a lot that was coming together in order to make all of this work. But it works. And it works on Linux and it works on Mac OS as well. And so I was very pleased with that. Yep. And then we got links now for each of the error types. So you're always going to get a link here that gives you an entry in the book that describes that particular type of the error, what you can do about it. Sometimes nothing, other than just fix it. Right. Okay. We need to resolve stack traces. We found that we can print them to a string. But I realize now that printing to a string is going to suck as well. Because we want to be able to split up all the data. Does this formatter have a way to like do the formatting and then just give us back like the formatted stack trace? No. You either print or you format to a string and that's it. Motherfucker. Yeah, so basically we're doing, I'm doing some of the work, which is like here's some regex work that allows us to select the namespace and the function name as well as the arity. And then I'm also doing some other cleanup on the symbols. But then the CVP trace formatter, which is this third-party library, is also doing some cleanup on the symbols. And so this is trimming out template arguments and function parameters. And this all happens as part of printing the stack trace, but it doesn't seem like it's possible to actually do this without printing it. Damn. Damn. Yeah, just format and print. So like we could format it to a string and then parse the string, but that's gonna suck. Or we could clean it up with this, but not benefit from the pruning of the template parameters. So there's a prune symbol. Oh, they have, ooh. Prune symbol. Prune symbol. We could call this ourselves. Okay. What do we want? We just really want pruning and prudifying. But then there's also hide exception machinery. Yeah, there's also the hide exception machinery. And we're not going to have a way to skip that. Oh, wait. Can we just call this function as well? This is part of a impl namespace we can see down here. So in C++ terms, that means don't touch me. But okay, I think we could do it. So that should be it. We need to resolve prettify and prune, and then we need to hide the exception machinery. So let's do that. let me take a stack trace, and then I'm going to just say resolve, which is really selling this function short compared to what it will be doing. But we're going to do a trace resolve, and oh no, because this is already resolved. So we should just take a raw trace and resolve that. And then auto resolved. And we don't want that to be const, because firstly we want to move it on return, but secondly because we're just going to be changing it. So once we resolve, then we are going to want to go through every frame, and we're going to want to do this transform frame on it. But we also want to prune. So let's do that. So for auto frame in resolve frames, we're going to say frame is equal to, and this is going to be CPP trace prune symbol. Yeah, actually, we're just going to be changing this symbol, frame symbol. And then we're also going to say frame is equal to transform frame and frame. Now this takes a copy and moves it. So we should just move this. Move it in, get it out, and then the final pruning. And then the last thing will be, we need to get the start. And so that will be a CPP trace v1 impl. Where did that go? We weren't looking at that here. It wasn't here. Right, I've already... hide exception machinery is where we got there. Hide exception machinery. So we are inside of formatting, get trace start. And so this is formatting v1 formatter impl get trace start. Is this a member function? Fuck, it is, because we have a const right here. So you can only have const on a function if it's a member function. So this is a we might just need to yoink this code out, which is always great when the code is like scary enough that it warrants a larger comment than the actual code itself. Like this is a 7-line comment for a 6-line chunk of code. I mean, I was only partially saying to advance in jest. Yeah, I think because this is pimpled, we can't actually get to it directly. So we need to reach in and grab it out. And This is going to want ranges. That's fine. Go for it. This is always adding a double comma. That's fine. Stack trace frame. Yep, sure. CBP trace. Const goes in the right place. What do you want now? Couldn't find, what the fuck? What do you want? What do you want from me? You gonna tell me this doesn't compile? I just... All right. We're undoing the ranges change then. This ought to compile. From the point of view that C++ templates are part of the type system, you would turn complete compile time meta programming language hiding inside of faux declarative syntax was the biggest appendage you could blow off. Yeah, I mean, the fact that you have a Turing complete metaprogramming DSL is your biggest appendage. You know what I'm saying? Had to finish up some work. What did I miss? Have we been productive? This should be frames. Also, this should be resolved. Yeah, I don't think you've missed that much. We're still doing exception stuff. It's just getting good though. Trace resolved. If anything, you skipped the boring bits. Not that anything on this stream is boring. All right, we can try the ranges now. Okay. If it's equal to the end, then 0, otherwise, blah, blah, blah. Okay, so now we should be able to just drop the frames. Hey, Goose Poppy. Welcome, welcome. Hello, hello. Welcome. So I think we want to just remove 0 to start. Is that going to work? I want to remove from begin to monumental results require cavalier usage of your base appendage. Yeah, that's what I'm saying. We actually want this to be const as well. I don't remember if vector erase is gonna be happy with this. We're gonna need to take a look. You know, we had Cogwheel here earlier. Cogwheel, are you still here? If so, Cogwheel gets a special shout out. So the second one removes elements in the range first, last, and so that does not include the last. So what if first is equal to last? Emptying, erasing emptying, just nice. Cool. So that means I can do this, and if start is 0, that's going to be fine. Nice. Should I make a Raylib game in jank right now? Yeah. So, Joseph, we have this thing called the jank commons, and I don't actually know if I have Raylib in here yet. I do. So I have Raylib in here already. Nice. So what this means is, oh, do I actually have, let me check. Oh yeah. So Joseph, when it comes to working with third-party libraries, you should really take a look at this jank build system chapter of the jank book. And I don't think anybody's read this yet, but that's I'm not yet like pushing for people to really use jank for everything. That's what's going to come at Clojure Conch in a month and a half. But jank has already the ability to have a cargo style build system where you can bring in native dependencies either that you build from source and it'll help you do all that stuff automatically, or that you bring from system packages. And I have some guides here for how to package system libraries as well as source libraries. And the guide for packaging a source library actually goes through how to package Raylib from source. Now, to be fair, to be clear, we already have Raylib packaged. It's just part of the jank commons here. So all you need to do is just add, like this is on Clojures. So all you need to do is just add Raylib sys, 2026-07-1 from Clojures. You can just pull that down. But this will give you, if you go through this guide, it'll give you a lot more info on like how it's actually working. And as part of this guide, we end up just writing some Raylib code that runs, with the package that we just packaged. But yeah, this is what like a hello world in Raylib looks like in jank. Once you add that package to your Leiningen dependencies, all you need to do is just do an include. And then everything is exposed to you from there. What game should you make? Oh, whatever you want, bro. Have you made games before? Yes, quite a few. Oh, great. So what game should I make as a flex then? You're like, name it. Name it. I got this. Maybe. Have you made Minecraft yet? Or a Minecraft-like voxel game? No voxels yet? I think that that's a fun one. Really, the thing that I think about for this is early on for jank, which is like, you know, now and in the coming months, we want to make things that are just visually appealing, because we want to make things that and that doesn't mean that they need to be realistic. It just means they need to like be interesting to look at. And so that can even mean like basic visualizations of things, you know, like that's like, there's someone I follow on Twitter that makes like the using math, using just like math formula can make something, can make points move like a jellyfish, you know, like and people love that. You get thousands of followers, and it's just like there's no color. It's just points moving in an interesting way. I think that in terms of helping to grow a community and getting people interested, the thing that we should just be focusing on is first whatever's interesting to us, because that's what gets us to do this stuff in the first place. But then within the bounds of that, whatever's just visually interesting to other people. So I don't actually know what that would be. Like, I think Minecraft is visually interesting because people just like the look of those things. But there are a lot of things that are visually interesting. One of the things I want to make with jank eventually is like some sort of music visualizer that, you know, synchronizes with music and then does interesting patterns procedurally. I don't like, I maybe like you set up a sort of scene with some parameters, but then the rest happens procedurally. That's the only input that I have for a game. But then again, make whatever you want. I mean, the number one thing is to just make something. If people are making whatever games they want in jank, I'm happy with that. Share it with me so that I can share it around though, because I wanna get those videos and pictures onto every like social media and chat channel I can, so that people can see, you know, what jank can do. You just make that one game. What's that one game? Is it Survivor-like? Third-person World War II combat with puzzle elements? What the fuck is that? What's that from? I mean, cool, do that, but like, but is that a game? Is that like a known game? Feel like you're yanking my chain here. That's a combination. Yeah, okay. That's what I was thinking. I'm like, I don't know. Platforming, third-person World War II Animal Crossing game with proximity chat. It's a shooter, but you command squad stars in RTS. Yeah. And by that you mean it's turn-based, right? Divinity style. Yeah, real-time turn-based. Right. Okay, so we have the ability to resolve stack traces to get started. All right, let me know when you're done. Couple hours probably. Real-time turn-based E33. Cool, be right back. All right. I don't know. E33 is a pretty low bar. See if you can just, you know, shoot a little higher than that. Said we wanted it to look good after all. I've been playing Big Walk recently. Did you guys play that in the release? It just came out within the last week. We got this resolved. So we're gonna have a resolve trace and a stack trace. And then we're gonna need a thanks for the prime, Emmy Hales. Hope you're doing great. ExceptionInfo. You been into Cyberpunk? Yeah. You know, my neighbor was actually just talking up Cyberpunk to me. And I haven't played it yet. But I just had a friend telling me that he was playing it, an old game dev friend. And then my neighbor was also just telling me about it. Maybe it's time. Maybe it's time to jump in. What's the Proton DB support for Cyberpunk? Gold. It is deck verified. I see. Yeah, most things work pretty well for me. So my guess is that this would probably work out of the box. I also have NVIDIA card. Okay, so what we want to do here is if we want to say if raw trace get and resolved trace get, actually better yet, we'll just say if resolve trace get early return. And then, yeah, or raw trace get, yeah. Then that means that we know we don't have a resolved trace, that we do have a raw trace. And so then we can say resolved trace is equal to make unique CBP trace, stack trace. And then here we're going to expose this function. This is part of jank util. We're gonna need to forward declare that. So we need raw trace and stack. Oh, but this returns a. Oh, no, we don't need to. We already have an include. Okay. And what don't you like about that? Oh, okay, fine. So here we want util and this is going to be resolve. Raw trace. And this takes in that by reference. This is in jank util. I don't see why that would be an error. Resolve, did you simply mean resolve? I think it's right. I think we just need to include. No, util. There we go. All right, so now we have a way to actually resolve the traces. So let me just call resolve here. Is not a const function. So we either const cast or we make these guys mutable and make this const. We lose either way, but this has to be const because this is not meant to, like this is part of the virtual interface. I'd rather leave resolve to be non-const. That way, it's part of the public interface. Anyone trying to call it, it's clear. What does constcast do? Constcast can either add or remove const from a type. That's it. So in this case, because this member function is const, this is a pointer to const ExceptionInfo. But I want to call this member function resolve that is non-const. And so I const cast this to a pointer to ExceptionInfo. So we're casting from pointer to const ExceptionInfo to pointer to ExceptionInfo. And then I can call resolve. So I have two options. I can either const cast here to remove the const from this, or I can add const to this resolve function, but then I'll not be able to actually change resolved trace here. And also not just resolved trace, but raw trace, which I'm going to reset here. And so I would have to, if I made the resolve function const, I would have to go to the header and I would have to make these mutable. And mutable in C++ means that something can be changed even in a const member function. And I would rather leave the resolve function non-const. That way anyone who's using this as part of the public API can see that resolve is going to change things. And then the fact that we do it inside of toCode string, which is const, is just how it has to happen. So that's why I chose to do the const cast here rather than make this const and the other members mutable. Sure thing. Okay, so now we're resolving that trace. Let me just do, wait, that's not what we wanted to do. We wanted to do xinfo meow. Yeah. Okay, so yeah, now we have a resolved trace. We can actually do some stuff with our frames. And so we're gonna want a helper that converts a stack frame into a vector. So let's just do that. Also, I'm just gonna change the result of this to a persistent hash map ref, because we can. And so I'm going to do this as a persistent vector ref, and then we're going to say frame to vec. And I'm going to fill up my water and use the restroom, then I'll be right back. All right. Just making a note. So we don't need to worry about licensing for something as short as this, but I do still just want to call out that that was copied from CPP trace. And so now we are taking a stack frame, which is a CPP trace stack trace frame. We'll call that frame. And we are going to convert that to a vector. So the vectors are So DJ Blue, how much does this matter? Because like invoke and invoke static don't make sense in jank. And then the symbols, that's the first element of the vector, can't be symbols in jank because they have to be strings. So it's looking to me like we can have a string for the symbol. I'd probably just skip invoke and invoke static, and then have a string for the file name, and then a number for the line. Is that still doable? You think on your side, or is that a real pain in the ass? Yeah, this even has like apply to and apply to helper. What is these? Oh, this is the function name. And then this is the type. I see, that's what's going on. Yeah, I mean, that separation just doesn't make sense for us anyway. In Java, everything's in a class. In C++, we look at the stack frames like most things are not in a class. You know, these are just in namespaces. And then, you know, main's not in a class. This is not in a class. Yeah. So we're just going to have a string for the symbol, a string for the file, and a number for the line. So we want a runtime, that's not how you spell runtime, runtime detail transient vector. And this is not very usefully named either. So we just have set pushback. So we want to add the symbol. That's a string. And so we just want to do a make box on that. Give us a box string. Then we want to do the file. That's going to be a string. And then finally, we want to do line. And then we want to return a make box of object persistent vector. What is line? Oh, it's nullable. Value or 1. I don't want to make shit up. I'd say if we don't have a line, do all these have lines? They all have lines. If there's no source file, they still put 1. So let's just do that. Also, if I think what we probably want to do is check if file name is empty. File name is never going to be empty though, right? For some, if it's not properly symbolicated, then file name could be empty. Yeah, I'm not going to worry about it. Okay. That's frame to vec. Now we want to put this above here because we want to, here, we want to set at, but we only want to do that if e raw trace. No, we want to check stack trace. Resolved trace. Else if e, no, because it has to be the resolved trace. If we have a resolved trace, then we can grab the resolved trace frames at 0. I'm gonna use dot at to throw in case we don't have something there. We should, but we might not. And it would be undefined behavior to assume. This was renamed to just trans. All right, let's try that. We should actually get something for our via now. Yeah, the difference though is that we are specifying the full path here and everyone else is doing, they're just doing the file names. So we want to take that. So this was being done for us by the formatter right here, paths, base name. So here's the detail base name. Maybe Windows. Interesting. This is just doing some straight up string replacement. It's actually not even plugging it into a standard file system path. It's a bold move, Cotton. See if it pans out for him. But this is CPP trace v1 detail base name. I'm just going to call that. So we'll say frame file name is equal to CPP trace. We don't actually need to do v1 detail base name frame file name. Is base name forwarded? Say what? Nice, like that. Okay, so now we have those vectors. Now we just got to do that for the rest of the trace. Let's do Yeah, so we just got to loop through the other causes right here. And then we have to do the trace right here. So let me yoink this here. And then we're going to do that here. And then trace. So trace drops to a new line. And new line and also indented. And then we start on our vectors. Our vectors all hang. So the first one has no indentation, and then all the others have 2 indentation. I really don't know if it matters to like pretty print this, but I've noticed that this one is pretty printed, so I'm just doing it. I think it's meant to be easier to read. And we don't actually have pretty printing yet. Like we don't have Clojure.pprint. So might as well. This is basically how I did the IR printing, except for the IR printing I had something that was a little smarter that detects the indentation to automatically handle hanging, because we had a lot more just arbitrary code that that needed to be printed. So I had like determine indent and then print indent, and then I think the indent was actually just a variable that you could just increment like so, and then so you print the indent. I'm not going to bother with something like that right now for this. Might be nice to generalize something like that, but since I think we're going to be implementing Clojure pprint anyway, although Clojure pprint's kind of a mess. I don't know if you ever looked at the code. And the result that you get is oftentimes not that good looking. So needs indent starts with false and then goes to true, and then we loop through all of our frames. So we'll just say frame in, and this is going to be in the resolved trace frames, and then needs indent goes to true at the end. And so we'll say if needs indent, then we will format in an indent of 2 spaces. And then we format in our vector, followed by a new line. And our vector is a frame to vec of the frame. I think that's it for the trace. Frame to vec. So that's going to be a vector. I need to do a to code string on that. I wonder if it makes sense to trim out the CPP trace stuff. Do we do that in... yeah, we have a filter. We have a filter. Yeah, we do have a filter here. This returns true if the frame should be kept. Maybe we should filter. Filtering is done. What's a good function? There's remove if. There's remove if. Resolved frames begin, resolved frames end, and then our CP trace stack frame. That we need to return filter frame, but we want to negate that. What is this returns the iterator. I don't know if remove if is the cleanest way to do this. There might be something in the ranges. This gives me back a it gives me back an iterator that's no discard. Returns a past the end iterator for the new end of the range. That's fine. I don't really care though. Like, I don't care about the new iterator. I just wanted to remove the stuff that was in there. Oh, because you need to combine, I forgot, you need to combine this with erase. Yeah, so you need to do erase. So what remove if does is it actually shuffles everything to the end, and then it gives you an iterator back to the new end, and then you do an erase of the new end that's returned with the original end, and then that removes the stuff at the end. It's such an odd thing. But that's fine. So resolved frames erase, and then resolved frames end. And then this is going to be complaining about the range, and I would accept that if there was a code action for it, but it doesn't seem like there is. Even though it says fix available. Okay, so we should be able to... Nice. So all the CPP trace junk stuff was removed. Ooh. All right, DJ Blue. So if we need indent, then I'm going to do a new line and then 2. I think that should work there. clipboard operation not allowed. Okay, nice. That looks good. So let's yoink that and then go here and try to paste. That didn't work. Let me see if I have unmatched delimiters. So there's an open, open, close, open, 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 close, open, close, close, close. Trace vector needs closing? You're right. Okay. Paste, paste, paste. Eden. Error, trace. Via. So is this format gonna work with your stuff? Yeah, so keep in mind that like the trace format for the vectors is different because we have a string for the symbol rather than a symbol for the type and then a symbol for the function. And so if you're looking for like a vector of symbol and then string and then number, then that's gonna be different. But those just don't make sense for jank. And so I've broken the shape. Yep. It's very nice to just be able to dump some Clojure data into here, though. Yeah, I think as long as you can support the 3 vectors with the string number, then that would be good. We'll see who else that breaks. I don't know who else is building tooling around this. This is exception data. Ah, and then here's the trace. Yeah. Why does this have multiple things here? Isn't each trace entry just one vector? Why is this actually like a range? Oh, you're grouping them. Fancy. Fancy, fancy, fancy. Yeah, okay. Well, if this can work for you, then that's great. And then throwable to map cause. Yeah. Okay. So the other causes, we haven't set that up yet. So we need to set up the other causes. We need to handle this toString. And then we need to implement the throwable to map. Aside from that, I think that's it for the exception objects. As Phronmophobic says, easy. Is there anything else that you need from this, DJ Blue? Or is this gonna work for you? So we had core.jank. So ExceptionInfo is going to create these ExceptionInfo objects. XMessage, XData, XCause are all going to work on those. And then we don't have throwable to map even in here, but I'm conflicted on the name because throwable with an uppercase T is actually a Java type. And that type obviously doesn't exist in C++ and it doesn't exist in jank. But it's not like I have a better name for the function. Although I might call it like xmap, like ex-map. That way it fits with xmessage, xdata, xcause. I don't know. I'll have to chew on that. I don't like bleeding JVM internals into, into jank just because they were in Clojure JVM. Hey, mashed potato, welcome back. But then again, I don't like breaking people's code just because I don't like bleeding JVM internals into jank. So it's kind of a lose-lose. But it's all right. I'll think about that, and it'll be implemented either way. Yeah, ideally I want no Java in jank. Thank you very much. It's kind of wasn't that kind of the point of all this? Wasn't that the point? I don't know. Yeah, pretty much. Clojure. All right. I think I'll wrap up here. I started a bit later today, so ends up not being about 4 hours, closer to 3.5. But I know that DJ Blue, I know you were hounding me to get these exceptions implemented. So hopefully that helps. Try to get this merged, and then the what's coming up is more of these error reporting improvements. I talked about going through all of the thrown errors and revising all of them. That way, whenever you get any sort of runtime error from jank, you try to call something that you shouldn't call, or you pass an argument to something that doesn't implement that particular behavior, you should not get back a dumb looking error like not derefable, or not seekable. Like, you should get a nice complete sentence that says what was expected and what was received, and maybe even what you can do about it. And so all of the error messages are going to be updated for that, and I'll have a style guide that I'm going to be adding to the repo that's going to apply to the compiler runtime, as well as all of the other projects that are inside of our mono repo, like the Line Again Jank plugin and so on. And that's the bulk. Looking at this list here, that's the bulk of what's remaining for runtime errors. And then I still need to jump in and do the C++ interop errors, which is just a whole other can of worms that is yet to be proven how viable it's going to be. But we'll do the best we can. I think I've been very impressed with what has been doable in the error messages so far. So I'm hoping I can keep up that momentum and success when it comes to the C++ interrupt. And then, so yeah, in terms of the big priorities, docs, Clojure test suite, still need to get brew, x86, source info is what I'm working on now. Error reporting, C++ sources, that's what's coming up next. Build system stuff, AOT. DJ Blue is actually handling the array stuff. He picked that up from me. So shout out DJ Blue. And then not much else that was actually required for the beta. Embedding is probably the next biggest thing. Yeah, we're looking good for the conj. We just gotta keep it up and keep pushing through. But yeah, for the conj, we're gonna have documentation in place and examples and build system support on Linux and Mac OS. So it's going to be really easy to just spin up a raylib game, or a whatever, or start packaging your favorite native library. And then I can spend more time on my streams just writing some software in jank, both to test jank out and dog food it, but also because there's actually some software that we need to write. So I have some development tooling in mind that's going to be amazing. Think of it as a tool that you would run alongside your development, that's just going to help you inspect your program. Not necessarily your running program. Like, it could also, I'm imagining static analysis as well. Static analysis as well as runtime analysis. And maybe even a debugger built into that, since someone was asking about that earlier. I got a lot of ideas when it comes to development tooling. But we need to write an LSP server so that people who are working with jank can not only benefit from Clojure LSP, and maybe we can compose that, but also all the C++ side of things, get C++ completion and suggestions and everything like that, as well as LSP features like renaming, jumping to definition, everything. Having an LSP for jank that's hooked into both Clojure and C++ is going to be amazing. But that is I don't know of any LSP servers that are handling 2 different languages like that. So we're gonna we're gonna have to figure out how that works. But we might as well write that whole thing in jank. I don't see why not. Makes sense. So until then, had a good one. Hope you guys did too. I appreciate all the new subs, all the new follows. Today was a big one for that. I'm still trucking along, working toward the conch and everything that I want to be done by then. So until next week, have a good one.